to walk around this truck and identify the parts. I know that some of you already know about the truck. Some of you are new to it. It's most important that you interrupt me and ask questions. My whole job is simply answering questions. So if you guys have a question, let me know. If it comes to something that we're going to be doing in the future, I'll let you know. I'm here to tell you that there has never been a time that this truck has not made the exact concrete that somebody wants. There are thousands of these trucks on the road today. They are pouring everything from federal highway bridge decks to simple flowable fill in the ground. They pass every single standard. Within its realm, it can't pour 9,000 pound structural concrete. It has never failed anyone's test. So I guarantee you, we can make it make concrete exactly like you guys want to see it. Let's start up here. As we go down this side, there's going to be 4 things. Now, who are my operators? Who actually run, not necessarily drive it, but who's actually in charge of pushing the start button? There are 4 things that I want you operators to look at every time you get ready to make concrete. So I've pulled up on the job, I've turned on my PTO, I'm heading towards the back. And I'm going to go over these 4 things specifically, amongst other things, but you'll know exactly what they are. Number 1 on the hit parade is, do I have water? Is my water turned on? You have a 510-gallon insulated tank. This is obviously our little level gauge. When you're down at the bottom, you still got about 100 gallons of water left in there, okay? That water tank goes all the way to the bottom. Water comes by gravity down this hose into our 3-way valve. Now, it's very easy to tell if my water is on. We've got an arrow right here on my valve, okay? We point it at what we want it to do. If I want to, in this particular case, you drained it, but if I want to fill it, I point it to my fill. If I want nothing, I point it at nothing. And if I want water, I point it at my water pump. It's very easy. These 4 things that we're going to talk about, I learned several years ago. And it's just over the years, my customers would call me with problems. And I realized that really most of those problems fit into one of these 4 things. And a lot of what I got were water. Pulled up to a job, turned it on, out came dry material, no water. In your specific case, maybe this truck was in overnight, the mechanics were working on it, they had to turn the water off, they were working on the water line, they forgot to turn the water back on. Here, it's normal, you guys drain these out, we drained it out, we simply forgot to turn the water back on. So, I've had some guys, couple, not a lot, customers, some of them get running in the summertime a lot. Back to the yard, get filled up, get back on the job. Back to the yard, get filled up. I've had a couple guys forget to fill up the water. It's understandable. So number 1, do I have water? Is my water turned on? Water flows through our water pump and through our strainer. And you'll notice that in this particular setup, this strainer is after the water pump. That's not normal in most water systems. You think of a water filter or a water strainer before it goes through the water pump. This is a robust pump. It will pretty well pump mud if you want to. The strainer is here for one reason. As my water flows down through my pipe, it goes through my electronic flow meter. This flow meter is a 4-bladed impeller. It spins freely and it's electronic. The ends of the 4 blades have magnets in them. As it spins, it gives information to the computer. The computer knows that let's just use a round number, and let's just say I need 25 gallons a minute in my yard. The computer already knows that. It supplies electronic signal to the hydraulic water valve, which opens its valve and supplies hydraulic fluid to our pump to turn it at an exact rate. Now, I understand you guys are having water problems. We're going to deal with that when we're out pouring. It's important to know that this truck will pour water to the 10th of a gallon of water. You can adjust the water so closely on this. This is the big reason why it's able to do that. It simply senses the flow of water through our water line, reports it to the computer so that the computer can control the hydraulic water pump in the end. Once a month, I want you to check the strainer, okay? If you're not doing it. It's fairly simple. Here's our strainer. Looks like it's nice and clean. Now, don't do this. Don't unscrew it. Look at the strainer. Looks good to me. And slam it back up in there. Guy that became a friend of mine has 3 of them outside of New Orleans, and we dealt with the water problem he had for a couple of days. Couldn't get a handle on the water, couldn't get a handle on the water. Now, when you call back to the factory, those guys are all factory trained. They're standing there and they're as smart as I am. And the first thing we're going to ask you, if you're having a water problem, is you checked your strainer. Well, I didn't ask the right question. I started to ask the right question after this. I divert from a job wherever I was. I go down there, and we had checked everything. We just couldn't get a handle on the water. And I pulled this out to look up in here to see if there was something clogging it. Water goes from the inside to the outside of this. That strainer looked perfect on the outside. It was full of crap on the inside, and that's what was holding it up. So when you're checking your strainer, make sure that the inside of our strainer is clean. Only has to be hand tight. This is our one-way valve. It allows water to stay pressurized at the back of our truck 100% of the time. So when you hit start, water comes out instantaneously. You guys are obviously already real good at draining things out. We have our drain here. Water goes through our flow meter, comes around the corner, goes through our water valve. You can see that there's an air line here. We're going to talk about this air line in a minute. Goes around, dumps down into our hopper. And that's how we get water. There's an arrow on this water valve. Now, I know you guys have mechanics that work on your truck, so you would never be replacing this. But if you ever wonder, you'll see that the arrow is going in the opposite direction the way it normally should. It's going upstream. We're using the head pressure of the water to hold this valve closed. I'll get a call every so often that the truck's leaking water, and I'll first ask them, did you put a new water valve in it? And a normal mechanic would look at that, he'd flip it over and put it in the direction of flow. We're using our air line to open it. We use the head pressure to keep it closed. For any mechanics that are with Murphy, water valves go in backwards. So that's our water system. Very simple. It's my water turned on. Number 2, 100 pounds of air pressure. And I see that you guys are keeping this good. It looks right on there. Obviously, it's just a little thing that we can take a look at as we're walking back to make sure we have 100 PSI. If we have to adjust it ever, this simply pops up clockwise, increases the pressure, counterclockwise decreases the pressure. Now there's a lot going on up here. This is our main air inlet over on this side. This air line is coming in from your secondary tank. On your secondary tank, there's a 70-pound emergency relief valve. If you'd have catastrophic air pressure failure, a catastrophic failure within this on an airline, it will only allow the air to go down to 70 psi, and then it will close that valve so you can get it back to the shop and get it fixed. If we need to turn air off to the entire body, we simply turn this valve right here, and that'll drain everything, and that closes it right here. There's no real reason to close that. It should pretty well always stay on, but make sure that we have 100 psi. We have an auxiliary air outlet, whatever you'd like to do. You can use it as a blower, you can fill up your tires, you can use it as an air chuck for cleaning. And then we have two float bowls. This one is an air-water separator. Simply crack this, and it would blow any water that it has captured during operation. Now, it's really kind of a holdover from older trucks, but new trucks have air water separators on them, dryers, everything. Something we need to check. And then also, it looks like you're doing a good job of keeping our airline oiler full. This uses automatic transmission fluid, and to fill it, simply turn off the air. If we wiggle it a little, we can turn it a quarter of a turn and pull it right out. Fill it up with our ATF. All this is doing is simply dripping 1 drop of oil in there every second whenever the vibrators are on, okay? Doesn't work with the fluffers, it only works with the vibrators. You have 3 sets, 2 sand, 2 cement, and 2 stone on the other side. Every time they come on, it will drip oil through there. How long it lasts is kind of a trick question, right? I have customers that pour 400 to 500 yards a truck a week. They're going to go through it a lot faster than you guys are. You tend to pour small batches. So we have a sight glass, just want to keep an eye on what's going on there. Here is our solenoids for our vibrators, and our fluffers are right down here, which leads us to our water valve, surprisingly enough. If we don't keep this at 100 psi, someplace around 60, 65 pounds, you're going to call me and you're going to say, I'm pouring concrete and it gets really, really dry for a second, and then it goes back to being normal, and then it gets really, really dry and it goes back to being normal. 100 pounds is important because these vibrators are air hogs. And what they're doing someplace around 65 pounds is every time they come on, they're stealing air from our airline back here on our water valve, and our water valve is closing for 1 second and then opening back up. So 100 psi, that's why that's important, to make sure it's that way. I have 100 pounds of air pressure. Hydraulics, a lot going on. Obviously the truck is hydraulically driven. Sorry about the noisy PTO. I'd love to tell you that we figured it out someplace how to fix that. We've tried every form of isolation method. The reason it's noisy is it's bolted directly to the frame of the truck, and you hear it running and the frame tends to amplify the sound. Nothing really wrong with it, they're just noisy. Oil, 32 weight hydraulic oil. You guys won't have to know, your mechanics would have to know. But oil is flowing by gravity through the suction tubes down to our PTO-driven hydraulic pump down there. Pressurized and brought back up through 1, 2, 3 circuits for our mixer, conveyor, and our up, down, right, left, and our water system. This is our hydraulic lines coming back to our pump. Pressure comes back, goes through our series of hydraulic valves. Nothing underneath here to service. Nothing normally that you guys would need to use, except for a couple of things I'm going to show you in a minute. This valve is for our conveyor belt. This valve is for the actual mix auger. This block of 3 valves is for the water, the hoist to make the mixer go up and down, and swivel it right and left. There's 3 things you need to know underneath here. You see that there's a lever right here, okay? And we can see 2 levers back here. If we have an electronic failure, computer shoots craps, something goes wrong somewhere along the line in the computer, and we still have hydraulics, these levers, and Murphy's Law says if my computer is going to shoot craps, right, it's going to do it right in the middle of a concrete pour. This allows us to manually operate our mix auger so we could get our concrete out of there. These 2 allow us to right and left, get our mixer centered, and the levers are actually backwards. Down is up and up is down on this one. It gets it back up into the hooks. More importantly, 2 buttons right here, little red buttons. And you can listen for the top one, runs those, and the bottom one runs this. If we had a failure, what we can do is manually open this up, and that's just a click of that valve. We could hold that, open it up, dump some water in there to clean out our mixer so we could get it back to the shop. Okay? There again, those are just emergency things. That screen's a computer. You have an A side computer here, and you have a B side computer on the other side that we'll look at. This is the receiver for your remote control. This is simply an electronic noise filter, and this is a CAN bus splitter. Other than operating those 3 levers, nothing under here you need to do. In my years of experience, it is much better to have this dirt on this and oil than it is to have it clean. Don't ever pressure wash it, okay? Only time you should do anything is if you had a hose go bad and a bunch of oil got down there, put some cleaner on it, use a garden hose, okay? It's water resistant, it's not waterproof, but it is definitely not pressure washer proof, okay? Better to just have it dirty. All our oil comes all the way through, ends up back at our return manifold. Comes back to our oil cooler, back through our filter, okay? So, number 1, do I have water? Is my water turned on? Number 2, do I have 100 pounds of air? Number 3, how's my hydraulic oil? Your hydraulic oil is perfect. Now, it's not as important during the summertime necessarily to take a look at the clarity of your oil, but it's important right now. This sits in here over the winter time. We have snow, we have moisture. Oil, as we know, can attract that if it's sitting for a prolonged period of time. All I really want you to see is, do I have the proper level, which is 2/3, 3/4 full, exactly where it's at, and how does that look? Is it nice and clear? I found a brand new one in Canada a few months ago, and this has an O-ring in the bottom of it, and we had pinched an O-ring when they were bolting it together, and it allowed water. It sat over the wintertime in Canada, and it allowed water to get in there. I knew something was wrong even before I started it because his oil was cloudy. You could tell that water had gotten in there. Any of you guys ever seen a hydraulic line go bad from the inside without leaking? Hydraulic lines can lose an internal wrapper. The filter will pick it up, but it'll turn that oil nice and black. So looking at the color is real important. And it's something that I can just catch out of the corner of my eye as I'm walking by. So water, air pressure, how's my oil? 4th, and arguably the most important, right? 3, 4, that's 4 fingers, that's 3 fingers, right? 4. Filter service gauge. And it's arguably the most important simply because you guys as operators are the first guy to see it, because we know if we've got water, we know if we've got air, and we know how this looks, but the PTO has to be on for this to run. So when it's cold, and it's still cold here, right? I live in the Midwest too. It's still in the 30s at night. If we take it out first thing in the morning, we might be up into the yellow. Give it 10 or 15 minutes to warm the oil up. Make sure she comes back down into the green. But if it's the middle of summertime and we click that thing on and she's all the way up into the yellow first thing and we know it's warm, then it's time to tell a mechanic, you know, it's time for an oil change in this thing. I've had them completely plugged where oil was not flowing. You'll really notice it because it won't give it proper flow and the operation of the truck will slow down. You'll know something's wrong with that. So those are the 4 things that we can look at as we're going past here. 510-gallon water tank, like we said. This is our aggregate bin, the big long one in the middle. It's divided 45% sand, 55% stone. So it's not exactly 50-50. We use more stone than we use sand. It can be reversed. You can fill it full of sand. You guys do flowable fill also, I think, don't you? No? Some people use it for flowable. They fill it completely full of sand. It'll do that. But sand on the left side, stone on the right side under normal operation. You guys that are drivers, you're professionals. And you've probably forgotten more about driving than I know. But I hold every CDL license that you can get. I have driven pretty much anything with wheels on it. These are the arguably worst driving things you're ever going to get in. All the weight is up there, right? It's not normal. If you're hauling that cat weighs what, 50,000 probably and around. We've got 30,000 pounds of aggregate on average. We've got 9,000 pounds of cement powder, and the majority of it is greater than 8 feet in the air. These are relatively top heavy. There aren't little mistakes. We have an entire division in our factory that just rebuilds them. They come in from back to our factory to get rebuilt from all over the country where they've flopped over for one reason or another. So just be careful as you're driving it. You guys are all used to, you people that are in concrete are used to hearing in concrete in terms of a 5-sack mix or a 6-sack mix or 5 bags or 6 bags. Deals with how strong the cement is. When they're talking about bags, that's a 94-pound bag of cement powder. This bin holds 115 bags of cement powder. 1 bag of cement is 1 cubic foot. That's 115 cubic foot cement bin. Now you lose some of that. In theory, you'd have somewhere around 11,500 pounds of cement full. You lose a portion of that to fluff, air within the powder. If you fill this up normally, you've got about 9,000 pounds in there. So remember, when you fill this all the way up, I filled one up for Con Expo in Las Vegas the other day, and I have to pay for the ingredients by weight. So I got to see and scale it out. And I just filled it up I wanted it nice and full because I can't leave the show, and I had to pour 5 days in the show. I filled it easily. That thing weighed 76,000 pounds and some change. I have people that run them at 80,000 pounds that are in the middle of no place. You guys are never going to get pulled over, right? The DOT is probably not going to torture the city of Toledo. You can get them good and heavy though. So you just want to make sure that you know that I'm driving something. It's easily filled at 70,000 pounds. So I'm driving something that weighs quite a bit. Our hose reel, you guys are blowing things out, and we're going to talk about that a little later, how to blow it out. It looks like you're doing a great job of blowing it out already. Gates. First, let's talk about how we make concrete. If you get a barrel truck, he's at the plant, right? He has a computer. He puts 10 yards of material into your barrel truck. They mix it up. They add this much sand, this much stone, this much water, and this much cement powder. Drives down the road, mixes it up. If they want stronger concrete, if they want to go from 3,000 to 4,000, they basically use the same amount of sand and stone. They add a little bit more water, and they add another sack of cement. Generally, 470 pounds of cement powder in a cubic yard will give you 3,000 psi concrete. 564 pounds, another 94 pounds, would be a 6-sack mix, and that'll give you 4,000 pounds of concrete. In a barrel truck, they know what that number is. They drop that in there. In a volumetric truck, we make concrete different. And this may be where some of your production problems are coming from, okay? You guys have the ability, and I'm not saying anybody's doing this, it's just I've done this once or twice before. If we have a finisher making concrete and he says, it's too bony, take some rock out of that. You can walk over here easily, let this stone gate go, bring it down, and take some rock out of your mix, okay? It's important to remember that if you ever change these dials from what the computer says they're supposed to be, you are no longer pouring the concrete you think that you're pouring. These are gradated into tenths, and unfortunately they're a mathematical calculation. They're not a measurement. If this is at 10.2, that's not 10.2 inches above the belt. Cement on this is a constant, okay? We have our two augers here. The top auger, the flighting, or the spirals of the auger, are divided in half, and they're moving powder to the outside of our bin. The bottom auger is called the metering auger, and it has the opposite flighting on it, and it's moving cement powder to the center, only it's enclosed, with the exception of about 1.5 feet on both sides, it's enclosed within a tube, and that tube is called a metering tube. When a barrel truck makes concrete, he dumps all his ingredients into his truck, he mixes it up, and he brings it out to you. And when he wants to change his slump, right, you just give me 5 more gallons of water, turns it on, puts more water in there, right? Becomes more liquid. When he wants that drier, he turns on the drying button on it. Oh no, that's right, barrel trucks can't do that. 25-year-old truck. This truck's only been out on the market 8 years. If you look at a 25, 30-year-old CemenTech truck, you'll see the exact same setup. It's one of those things, we're going to talk about it in the auger, it's one of those things that it's highly accurate. 2% plus or minus. I stand on federal highways with federal bridge inspectors that's their entire job, to make sure that everything is perfect. And I stand there with these trucks, and these trucks pour thousands and thousands of yards within an exact tolerance of exactly what it is that they want. We're going to be able to get a handle on you guys' curb and sidewalk. That's where our gates come in. If I want 3,000 pound concrete, I put 470 pounds per yard in it. If I want 4,000 pound concrete, I put 564 pounds of cement powder in it a yard. I just add cement, I made it stronger. That's the same way a barrel truck does it. We do it a little different. We take away or add aggregate to our cubic yard. So if we picture a cubic yard box, and we're pouring a cubic yard of concrete in there, and we want 3,000 pound concrete, it's going to have 470 pounds of powder in it. If our cement is a constant and we want 4,000 pound concrete, we want 564 pounds of powder, our cement's a constant. We can't make our cement go any faster. What we do is simply take aggregate away from that cubic yard. That makes our cubic yard richer or leaner of cement powder. I tell you that long drawn out story because if you're ever tempted to change these things, when I calibrate these and I want about 200 pounds of rock, okay? An average cubic yard has 4,000 pounds of material. If I want 200 pounds more rock in something or less, I can move this 2/10 of that and change that cubic yard. So if you walk over here and you say it's too rocky and you're grabbing this thing and you're going from 7 to 6, think about how much you're changing that cubic yard and how much inside there that you're doing. Ultimately, we're trying to produce quality concrete, right? And it up. You're playing the yo-yo game. It's coming out dry. Sometimes it's coming out wet. Other times you're just not getting out the end of the chute. Generally, only 3 things are wrong. They've screwed up the mix design. They've screwed up the calibration, or somebody's playing with the gates. And I know I'm not saying you guys are doing it. I'm just saying that if we change the gates, it's always going to change our mix that comes out the back of the thing, okay? So enough about gates. We're going to see how it works. We know our cement comes in here, water's coming in here, sand and stone's coming down our belt, right? Coming into our mixer. Your mixer's in perfect shape. Does anybody remember how we measure the wear of the wear blades? It's very, very technical. You take your finger, you put it on that bolt, and you can wear these down to the top of your finger. That same unit, you will see the same exact mix auger design. It has never failed us, and it continues to be a proven design. This is an IBS Pump Master Auger is the technical name. IBS stands for an internal bearing system. This tube is filled with 90 weight oil, and there's a shaft that goes through the back of your mixer, and the bearing pack, which is about this long, sits inside this tube. 3 specific things. You can see that this part of this auger is normal spirals, normal flighting, and that normal flighting ends right here. Taking all our material, it's segregated, right? Sand, stone, cement powder, water. We're not mixing it together yet. This is the emulsifying section. It's making an emulsion. If we had 2 hands of concrete, one from right here and one from right here, they would be drastically different. We don't want it to mix yet. What we want to do is take that segregated material. We want to coat the rock with cement powder. We want to evenly distribute the rock and evenly distribute the sand within the concrete. Even distribution is what's important, but covering the rock with cement powder is the most important. As our emulsion stops right here, it moves into our mixing section, which is from right here to right here. And obviously, we have a drastically different setup. We have holes in the flighting. We have stub shafts. Think of a figure 8 set on its side. Our concrete emulsion is coming up this way, and it hits our mixing section. And it comes along on the bottom. It's folded on top of itself, brought back down, folded on top of itself again, brought back down, and then delivered through our delivery section. Now, Yortsoy loves this. I learned that from a salesman. How fast? And of course, we have it come off the belt. So in your particular case, it takes, is that 128 seconds to make 1 yard of concrete. So a little over 2 minutes. Okay. All right. Things that a driver operator would need to know. Once we have put our truck into position, turned on our PTO, we'd come back, turn on our control panel, and let down our mixer. This has an automated stow and unstow. So we would push the down arrow and it will release our mixer. Then we can use our joystick to put it into place. Once it's down, once we're finished pouring, we have a auto stow and it will center itself and put it into place. From the screen, first thing we do when we're ready to pour is we would simply pour concrete. Now, from this screen, you have two different options. If you do not want to start a printed ticket or a recorded ticket, you would simply select the mix design that you wanted, select our Class C, accept it, and as long as we move our gates into the proper position, this is saying our sand gate should be at 5.2, our stone gate should be at 6.9. As long as they're in the proper position, if we simply hit start, 10 seconds concrete will be laying on the ground. Now, as we learned yesterday, the first thing we want to do is press start so that we run material up our mixer. And as the first bit of material comes out the chute, simply stop it. Using our mixer joystick, we're going to do what we call charging the mixer. We're going to roll the concrete back a little in the mixer. We're going to roll it forward once in the mixer, and we're going to roll it back again in the mixer. Then we can look down in the hopper and we can see exactly what concrete's going to come out. If we need to make that concrete wetter, we can simply go to manual operation, open the water valve, put a little water into it, mix the concrete up within the mixer, take a look, make sure it's okay. If we want that concrete a little drier, we're simply going to touch the conveyor on button and only dry material will come into the hopper. We'll simply mix it up again, forward and reverse, until you see the exact concrete that you want right in the bowl. When that concrete in the bowl is right, simply press start and concrete will come out. The second option, once you reach this screen, is to start a ticket. And I think that's the way you guys are doing it. We simply select Start Ticket. Here we can enter a customer name, we can enter a job number, we can enter the location that we're working. Then we would select the mix design that we're going to pour, accept it, and then simply begin this ticket. And that takes us right back to the exact same pour screen. We're ready to do the same thing and pour concrete. It's important to remember on our pour screen, there's a lot going on here. We can see our live water to cement ratio. We can see our job total water to cement ratio. It indicates the exact mix design that we're pouring, gives us mixer pressure and mixer speed. But you can notice that these boxes over here have square corners and these boxes over here have round corners. If a screen has a round cornered box, you can touch it and something will happen. If we touch these, nothing goes on. Let's say in this particular mix design that we had calcium or NCA in our number 2 admix. And for this particular job, we wanted to add calcium. Normally when we pour this, we have no calcium in it. We could simply touch the admix number 2. You can see that there are 2 boxes here. One square, one has round corners. If we touch the round corner, let's say we want to put 150 ounces per minute in there. Simply select auto and go back, and we can see that it loaded it automatically into this mix design. Once we're done with this job and we turn the computer off and we come back to this mix design, that will be back to 0. Anytime you enter this into it from the pour screen, that's temporary. It's not set full time. If you get high tech enough you can actually come in here, and now I can add sand and stone moisture to my mix. It will take away from the water automatically. Now, I say high-tech enough. I don't show a lot of people this, simply because what happens is if I put 6% moisture in there and 4% moisture in the stone, let's watch what happens to our water. So right now, this mix design has 14.7 gallons of water per minute as a target. If I simply put 6% and 4% in there, and I accept it, now I'm only putting 6.4 gallons of water in there. You must have a moisture probe to be able to tell how much moisture is in your aggregate. If you don't have that, there's absolutely no reason to use this feature. It is mostly for if you're going to do real high-tech stuff, or maybe an inspector is there and they're requiring aggregate moistures and they need to know. That's really what that's for. We can do on this, from this screen also, we can do quantity pours. They use it a lot with shuttle buggies. I don't know if you ever use shuttle buggies. So if we go into the same one, preset auto amount shutdown, I can program this to shut off. If my little buggy is a third of a yard, 0.3, accept it. Now, you can see it gives me a target. Every time I hit start, it will automatically shut off at that amount. Don't forget to go back in there and turn it off. I always get the call the next day, my truck's running and it's only giving me a quarter of a yard. Any of these are adjustable. Let's say, now you can see that the target, whatever is in the target, is what is in that mix design. Okay, this number is what we've loaded into the mix design, 25 RPMs. Let's say that we have 6 or 7 finishers and we're going to do a bigger job with this, and we want to pour the same mix design. You can always come over here, touch that, adjust the target to anywhere from 25 to 50. 25 is as slow as it'll go, 50 is as fast. Now, it doesn't change our gates, it changes our production speed. Now you can see our water's gone all the way up to 29.5 gallons per minute, and it has adjusted all our add mixes to meet our 50 RPM production rate. There again, if you program 50, if we turn this off and turn it back on, the next time we go to that, it'll be back down to 25. That's if we just need a little quicker production. It's simply under manual operation. From here, I can... Manual operation, yep. This is our manual operation button. Anything I want to run on this truck manually is in manual operation. So at any time I can come into manual operation. I can turn on my mixer to go forward or in reverse. I can turn on my conveyor independently. I can turn on or off, open or close my water valve. This is the cement delivery auger here. I can disable that if I don't want powder. Don't ever disable that without putting the lever on the right side into neutral. If you disable this so no cement powder can come out, and you leave that engaged and turn on the conveyor, that thing will pack cement powder in there, and the slip clutch will go off on the side. We're already using our auto wash feature. It puts 5 gallons of water into our mixer, and then it uses the mix auger at real low RPM, and it washes it's designed to get our solids out of there. From here, we can see our oil cooler. Right now, the oil is at 72 degrees. It's set to have the cooling fan come on at 120 degrees. And we can do vibe control. So this will allow us to, like cement fluffers, that will allow us to manually use that. Now, on your new programming that we set up, we have these same vibe control buttons down here. We can run all 3 of those vibrators from these buttons. Water pump boost is for clean out. What we do is when we want added pressure to our washer hose, we can simply hit water pump boost. You also have an extra button so we don't have to go into here. If we turn that on, it turns on our water pump boost automatically. Pretty well that's it. Make sure that you have, if you turn one of these on or off, make sure it's always in, it goes back to auto or it won't come on when you pour concrete. Now, let's say we poured our concrete, we're done. We're simply going to end our ticket. It's asking you, do you want to print an extra ticket or not? We can set this so that it can print 1 to 4 tickets automatically. If you need more than that, you'd have to hit yes, I want an extra ticket. No, we don't want an extra ticket. And it's done, ready to go to its next job. Ticket history. If we want to pull up any tickets in the past that we have started, you have to have started a ticket for it to remember it. If you just went to pour concrete and selected a mix design, it won't record that. You have to have come in to start a ticket. But if we want to recall any tickets, simply ticket history, what year it was. I want to open that folder. What month it was. I want to open that folder. What day it was. Open that folder. And then there's the ticket that we printed on that day. And we would simply print the ticket and it'll print it in the cabinet. Okay. That's how you work the ticket history. If we want to erase any calibration files or anything that the computer has stored, it is within file management. From the home screen, we're going to touch equipment parameters. Right down here is file management. Now we can see everything that's in our truck as far as the computers go. All the ticket histories, all the color calibrations. But let's take mix design in this particular case. Simply highlight it, open our folder. Now, anything that we highlight, default, delete, yes, it's gone. CemenTech doesn't have it unless you backed it up on your thumb drive over here. It's gone. So from here, you can manage any extra mix designs that you have. When we want to go back, simply go up 1 level. Now we can go to, let's say, aggregate calibration. You want to open that folder. Now here's everything that we have calibrated in there. You may not use it for the water department anymore. So these were their things. So let's say we want to get rid of those calibrations. There we go. Now we've cut down our aggregate calibrations, any mixed designs, we could go back any ticket history. That's how we would get rid of that. These files that I put in here, coming up one of these days, soon, I'll be able to send you a thumb drive with the newest programs on it. You'll simply be able to plug it in and you guys will be able to update it yourself. We don't update these trucks very often. The only updates we do are generally for bug fixes and things like that. It's not like your home computer where you get a new update. It won't make concrete faster or better. So there we go. That's it. Mix designs. When you want to enter a mix design is simply a recipe for a cubic yard of concrete. Simply edit mix design. Do I want to edit a file that's in there, or do I want to create a new file? If I want to edit one, I'd simply select it and open that file. If I want to create a new one, I would simply create a new file. Always name the files clearly. Streets is not a good thing, or curb mix is not a good thing. Name it something clearly. Today we're going to name this one test. Simply hit OK. Whenever you get to a red screen on our truck, slowly and carefully read everything from top to bottom. A mistake in this screen, the truck will do its very best to do it. So if we tell it accidentally we want 180 pounds of rock instead of 1,800 pounds of rock, it's going to try and give you 180 pounds of rock. But it's fairly simple. Enter the material amounts required to make 1 yard of concrete. The mix design file I'm working on is named test, and I'm simply going to go down and read every line. Of all the mistakes I have with customers in mix designs, it's because they didn't go slowly and carefully, and they simply didn't read exactly what was going on. So this is our cement, and you can see that it says cal file, so calibration file is what that means, and it's blank. Select a new cement calibration file. So we have to tell the truck, what cement do I want to use? It's normal for companies to have a couple different types of cement. Some may have rapid setting cement, some might have type 3. You have IL, you only use one cement, so you're only going to have a cement calibration file. Mix designs. When you want to enter a mix design is simply a recipe for a cubic yard of concrete. Simply edit mix design. Do I want to edit a file that's in there, or do I want to create a new file? If I want to edit one, I'd simply select it and open that file. If I want to create a new one, I would simply create a new file. Always name the files clearly. Don't, streets is not a good thing, or curb mix is not a good thing. Name it something clearly. Today we're going to name this one test. Simply hit OK. Whenever you get to a red screen on our truck, slowly and carefully read everything from top to bottom. A mistake in this screen, the truck will do its very best to do it. So if we tell it accidentally we want 180 pounds of rock instead of 1,800 pounds of rock, it's going to try and give you 180 pounds of rock. But it's fairly simple. Enter the material amounts required to make 1 yard of concrete. The mix design file I'm working on is named test, and I'm simply going to go down and read every line. Of all the mistakes I have with customers in mix designs, it's because they didn't go slowly and carefully, and they simply didn't read exactly what was going on. So this is our cement, and you can see that it says cal file, so calibration file is what that means, and it's blank. Select a new cement calibration file. So we have to tell the truck, what cement do I want to use? It's normal for companies to have a couple different types of cement. Some may have rapid setting cement, some might have type 3. You have IL, you only use one cement, so you're only going to have a cement calibration file. Using Lafarge cement, we're going to open that selected file. And now we can see that cement, our calibration file says Lafarge cement. We have to tell the truck, well, how much cement do you want? We'll have our mix design in front of us. And let's say our mix design says I want 600 pounds of that. Our sand file, cal file, what sand do you want to use? I want to use concrete sand. And my mix design says I want 1,400 pounds of sand. Now, first thing first, you can see as I do this, well, a gate setting of 1.7 is not really reality. That's kind of small. Most of them are in the 5 to 7. I'm going to show you what's going to change that in just a second. Same with stone. What stone am I going to use? I'm using Shelly 57. I'm going to open it up, and I want 1,600 pounds of that. And the gate setting's 2.5. Now what's wrong is you can see that our calculated rate of cement is at 0. It's because up here, and earlier I told you, if it has a square box, you can't do it. This is one of the exceptions. We have no mixer speed and no conveyor speed. Mixer speed is always 280, and our conveyor speed is however much production we want. In your case, you use 25 RPMs. Okay? We still have 0 cement in there. We still know almost 0, and we still have low gates. I still know I did something wrong. I gotta look at the screen. And here's where it is. It comes up automatically in low speed cement. As soon as I change that to high speed, now we can see that we got 4.7 pounds per second, 4.9 and 6.4. Brought my numbers into reality. It will take 24,522 conveyor counts to make our yard. And another thing, now we can see that we've left something out because we have a water to cement ratio of 0. Well, we forgot a water file. We're going to use our water calibration file. We only have one. Open it, and I want 25 gallons of water in here. Now we can see that it automatically calculated my water to cement ratio. 126.6 seconds, it's going to give me 11 gallons per minute. Next, and here we would do the same exact thing. Simply add mix number 1, number 2, and number 3. We would add the calibration file. In this case, in number 1, it's air. And let's just say we want 30 ounces of air in there. And you can see that it calculated it out. Now, don't get scared by this number. You can see we put 30 ounces in there, and our calculated rate is only 14 ounces. That's because it takes us a little more than 2 minutes to create a yard. So we're entering in the amount that we want per yard. We want 30 ounces in our yard, and it takes us 2 minutes to make 1 yard, so it's only going to give us 14 ounces every minute. Okay? And then we do the same for calibration. If we hit save, it'll save it, and it'll be in there. We won't hit save right now. Next. Nothing in the next for you. It would be where the fiber feeder or color feeder would be. And that's as easy as it is. So as long as we have a mix design, we can put it in there relatively quickly. Using Lafarge cement, we're going to open that selected file. And now we can see that cement, our calibration file says Lafarge cement. We have to tell the truck, well, how much cement do you want? We'll have our mix design in front of us, and let's say our mix design says I want 600 pounds of that. Our sand file, cal file, what sand do you want to use? I want to use concrete sand. And my mix design says I want 1,400 pounds of sand. Now, first thing first, you can see as I do this, well, a gate setting of 1.7 is not really reality. That's kind of small. Most of them are in the 5 to 7. I'm going to show you what's going to change that in just a second. Same with stone. What stone am I going to use? I'm using Shelly 57. Going to open it up, and I want 1,600 pounds of that. And the gate setting's 2.5. Now what's wrong is you can see that our calculated rate of cement is at 0. It's because up here, and earlier I told you, if it has a square box, you can't do it. This is one of the exceptions. We have no mixer speed and no conveyor speed. Mixer speed is always 280, and our conveyor speed is however much production we want. In your case, you use 25 RPMs. Okay, we still have 0 cement in there. We still know almost 0, and we still have low gates. I still know I did something wrong. I gotta look at the screen. And here's where it is. It comes up automatically in low speed cement. As soon as I change that to high speed, now we can see that we got 4.7 pounds per second, 4.9 and 6.4. Brought my numbers into reality. It will take 24,522 conveyor counts to make our yard. And another thing, now we can see that we've left something out because we have a water to cement ratio of 0. Well, we forgot a water file. We're going to use our water calibration file. We only have one. Open it, and I want 25 gallons of water in here. Now we can see that it automatically calculated my water to cement ratio. 126.6 seconds, it's going to give me 11 gallons per minute. Next, and here we would do the same exact thing. Simply add mix number 1, number 2, and number 3. We would add the calibration file. In this case, in number 1, it's air. And let's just say we want 30 ounces of air in there. And you can see that it calculated it out. Now, don't get scared by this number. You can see we put 30 ounces in there, and our calculated rate is only 14 ounces. That's because it takes us a little more than 2 minutes to create a yard. So we're entering in the amount that we want per yard. We want 30 ounces in our yard, and it takes us 2 minutes to make 1 yard, so it's only going to give us 14 ounces every minute. Okay? And then we do the same for calibration. If we hit save, it'll save it, and it'll be in there. We won't hit save right now. Next. Nothing in the next for you. It would be where the fiber feeder or color feeder would be. And that's as easy as it is. So as long as we have a mix design, we can put it in there relatively quickly. Admix system. You have 3 admix systems on this truck, and you can remember them simply by the size of their tank. You have a low flow system, and the range of the low flow pump is 5 ounces per minute to 30 ounces per minute. And you have 2 high flow systems. The range of a high flow is 120 ounces per minute to 330 ounces per minute. You can notice you're using air entrainment in number 1, which is normal. You're using water reducer in number 3. Tanks are not specific to the product, but they are specific to how much product you're going to use in your cubic yard. So in the winter time, we might use this tank for NCA or calcium for an accelerator. And in the summertime, we might have a retarder in there. Okay? So they will flow any material, depending on whether I need a high amount of flow or a low amount of flow. You can see that we dilute your air 4-to-1, and we dilute the water reducer 4-to-1 also. That's 4 parts of water, 1 part of admix. The reason we do this is that we want to get the solution into the flow rate of the pump. 5 ounces to 30 ounces a minute on our low flow. So we're going to use that for an example. Now, air entrainment from this particular company, they use 1 ounce of pure air entrainment for every 100 pounds of cement powder in your mix design. So in this mix design, for round numbers, we're going to say we're using 500 pounds of cement powder. So we would need 5 ounces of pure admix to go in our yard. If you remember from before, you're using, instead of 50 RPM, you're using 25 RPM. Because these flow at a per minute rate, we have to have them flow within their range. So if we were using 50 RPMs and we got 1 yard of concrete every 60 seconds, we could get 5 ounces out of it. But since we're using 25 RPM, now it takes us 2 minutes to get our cubic yard. So we're only going to get 2.5 ounces per minute out of there. So we dilute it so we can get that ounce rate up. These pumps are not necessarily reliable at their very bottom end, and they're not very reliable at their top end. We always want to be someplace in the middle. So what we do in this particular case is once we mix it, 4 parts water, 1 part admix, now we have 5 parts total. Don't make a mistake. Some people say, I've got 4 to 1, and they say, I've got 4, because this is math. I've got 5 parts. So now in my mix design, I want 5 ounces of pure admix, and I've got to have those 5 ounces times 5 parts, which is 25 ounces of solution I want in my mix design. That way, when I cut my belt speed from 1 minute per yard to 2 minutes per yard, I'm getting half of my 25, which is 17.5 ounces, which puts me squarely in the middle of my pump's range, okay? And that's why we mix any admix. This is the same thing, same idea, it's just higher flow. We only need 10 ounces of water reducer per hundredweight. So we would only need 50 ounces of water reducer, and that's below our 120 ounce flow rate of the pump. So if we cut it 4 to 1 for 5 times 50, we want 250 ounces of solution in our yard at 1 minute. We've got our belt slowed down, so that's 2 minutes. So now we're getting 125 ounces per minute to come out. And that's why we cut it, okay? Simple as that. You can notice you're using air entrainment in number 1, which is normal. You're using water reducer in number 3. Tanks are not specific to the product, but they are specific to how much product you're going to use in your cubic yard. So in the wintertime, we might use this tank for NCA or calcium for an accelerator. And in the summertime, we might have a retarder in there. Okay? So they will flow any material, depending on whether I need a high amount of flow or a low amount of flow. You can see that we dilute your air 4 to 1, and we dilute the water reducer 4 to 1 also. That's 4 parts of water, 1 part of admix. The reason we do this is that we want to get the solution into the flow rate of the pump. 5 ounces to 30 ounces a minute on our low flow. So we're going to use that for an example. Now, air entrainment from this particular company, they use 1 ounce of pure air entrainment for every 100 pounds of cement powder in your mix design. So in this mix design, for round numbers, we're going to say we're using 500 pounds of cement powder. So we would need 5 ounces of pure admix to go in our yard. If you remember from before, you're using, instead of 50 RPM, you're using 25 RPM. Because these flow at a per minute rate, we have to have them flow within their range. So if we were using 50 RPMs and we got 1 yard of concrete every 60 seconds, we could get 5 ounces out of it. But since we're using 25 RPM, now it takes us 2 minutes to get our cubic yard, so we're only going to get 2.5 ounces per minute out of there. So we dilute it so we can get that ounce rate up. These pumps are not necessarily reliable at their very bottom end, and they're not very reliable at their top end. We always want to be someplace in the middle. So what we do in this particular case is once we mix it, 4 parts water, 1 part admix. Now we have 5 parts total. Don't make a mistake. Some people say, I've got 4 to 1, and they say, I've got 4, because this is math. I've got 5 parts. So now in my mix design, I want 5 ounces of pure admix, and I've got to have those 5 ounces times 5 parts, which is 25 ounces of solution I want in my mix design. That way, when I cut my belt speed from 1 minute per yard to 2 minutes per yard, I'm getting half of my 25, which is 17 and a half ounces, which puts me squarely in the middle of my pump's range, okay? And that's why we mix any admix. This is the same thing, same idea, it's just higher flow. We only need 10 ounces of water reducer per hundredweight. So we would only need 50 ounces of water reducer, and that's below our 120 ounce flow rate of the pump. So if we cut it 4 to 1 for 5 times 50, we want 250 ounces of solution in our yard at 1 minute. We've got our belt slowed down, so that's 2 minutes. So now we're getting 125 ounces per minute to come out. And that's why we cut it, okay? Simple as that. Our valve has a 3-way valve, and it has a point on the handle. It's easy to remember because we point it to what it is we want it to do. If we point it to the solution hose, we want admix. If we point it at nothing, it's closed. And if we point it at air, we want to blow it out, okay? So let's imagine that we're full and we're going to blow this system out. We're simply going to turn our valve towards our airline. First thing we're going to do, take our strainer cup off. Drain the water out of our strainer or solution. It's a good time to check. We should be checking admix strainers monthly, okay? Simply put our strainer back on. We're working on admix number 2. Blow those out for the winter time because it's kind of complex on this one. We'll use this middle tank since we have it. Our valve has a 3-way valve, and it has a point on the handle. It's easy to remember because we point it to what it is we want it to do. If we point it to the solution hose, we want admix. If we point it at nothing, it's closed. And if we point it at air, we want to blow it out, okay? So let's imagine that we're full and we're going to blow this system out. We're simply going to turn our valve towards our airline. First thing we're going to do, take our strainer cup off. Drain the water out of our strainer or solution. It's a good time to check. We should be checking admix strainers monthly, okay? Simply put our strainer back on. We're working on admix number 2. Our admix comes all the way back to these 3 valves on the back of our truck. This is number 3. This is number 1. And this is number 2. If we have to remember we have 1 low flow and 2 high flows. We can see that there's a size of the tube differently. Okay, so number 1 is over here, smaller tube. Number 2 is right here. 3's on the other side. 1, 2, 3. What we have to do is we have to get this electronic solenoid valve to open up now, to blow it out. We use these valves so that those pumps can retain admix to this valve at all times. And we want to blow our lines out, but we've got to get this valve open. And that's what we're going to do over here. The easiest way to do this is simply touch calibration. And in this case, we're working on admix number 2. Admix number 2. Okay, we want to get our admix number 1 line opened up. Towards the air line, we want to open our electronic valve. We're simply going to come into calibration, and we're working on admix number 1. Select admix number 1, open that selected file. Now all we're doing is making that valve open up. And if we listen, you may not be able to hear it, but if I hit the start button, we can hear that open. You can hear our valve open. Now we're ready to come over here, and we simply follow our instructions. We want to blow that system out. So what we want is the water off, and we want air into the admix and the hose reel system. That's using this valve right here. So we'd simply turn that valve down to match that. And this opens and closes our air from our truck simply. We open this up, and we can hear the air. Now we're blowing air all the way through there to back here. If we leave that in the same position and we go over here, I'm going to close that valve, and we string our hose reel out,
Oh, you're going to blow that out too?
Yep.
Oh, okay.
So we use the same exact process. We want water turned off. We want air into our admix and our hose reel. And now if I simply add air pressure to it,
Okay.
I can blow the water in my hose reel out. Now, the mix system. Close number 1, go to number 2. Close number 2, go to number 3. Come into number 3. If we want to blow out our number 3, simply close these valves. Open that valve. That's 3. Yep. Now, see, that one hasn't been being cleaned at all. We'll clean it in a minute. Make sure our valve's pointed at our air line. Admix number 3. Water reducer. Listen for my valve to open. Add air. I'm simply blowing air right out the valve. Make sure you turn off the air before you turn this off. That's all there is to it.